that you can. Remember that from last week that a parabola is the same as a quadratic equation that has been graphed. So a parabola could look like one that we had a while ago, where it crosses the x-axis in two places. And in that case, it has two real zeros. And remember last time we said that it was interchangeable to say zeros, x-intercepts, answers, solutions, roots. All of those are interchangeable almost, with the exception of sometimes it'll ask if it has an x-intercept, and this does, it has two. But sometimes it has one or it has none. So you'll have to watch if it says x-intercepts or not. We could have our parabola come down and just touched. We talked about that the other day. Can just touch the x-axis, and then it has one answer. And I told you it's called the double root, but we'll talk about that again later. It has one answer because it's just touching in one spot. And then we have the kind that will be off somewhere. It could be up or down, but it's not crossing the x-axis at all. It has no real solutions.
I don't see your screen anymore for some reason.
You don't see my screen? Is anybody else having that trouble? Let me get it. Let me go back to video and back there and see if it helps. Okay.
Now I was able to see it okay.
Can you see it now?
No, I think I might have to just go out and come back in.
Hi, Chandra. How are you?
Hey, I'm good.
I'm going to count you here.
Maybe your router. Sometimes I have to restart our router because it'll make things look fuzzy.
I'm here too.
You're here? Is that Sequoia? Okay. That part. Did Selena ever in? Let me see if Selena's here. I don't see Selena. Okay, well, I'm glad you guys are in. Just hang in there if you can. If you can't see it, maybe go out and come back in, or try a different way to get in and see if it will work. I will also put the video if it
I'm
works.
here too, Miss Sullivan.
I'm sorry? Who was that?
Margaret. I'm here too.
Oh, Margaret.
Margaret.
Okay, Margaret.
Yeah.
I got you. Thank you. So I'll put the video of it out there too if I can get it to work. Last time it took me a long time to get it out there, but it finally worked, and I trimmed it so it just has the major information, but you can also use that to go back to, and it will probably play for you, hopefully. Okay, so everybody understand kind of what it looks like, and these are parabolas, but they're the graph of a quadratic equation is what those are. So section 4.8, we're going to have a few application problems that I know y'all don't like, but these aren't too bad. And then there's a huge section of quadratic expressions and equations that we'll be working tonight. Now, we did one of these earlier tonight because it was on one of our other problems where the graph crossed the x-axis and it crossed in two places, and the actual numbers were there in the ordered pairs were already there. And it asks for the x-intercepts. There's another set of these problems that you're going to see where it asks for the x-intercepts. Remember, if it's asking for x-intercepts, it's probably going to want the ordered pairs. So -2, and don't forget to put this little comma. I don't know if they're counting it wrong or not if you don't put that little comma, but be sure you put a comma between your two answers. Then it says the solutions are. and then it has a blank there. That's where you can put -2, 2. See the difference between writing the x-intercepts and the solutions. So this is the second kind of set of problems where they're giving you a graph and asking you to find different things. So now then, let's talk about the Pythagorean theorem. I know you've probably remembered the name, but you might not remember what it does. It's a squared plus b squared equals c squared. And the deal about that is you have to have a triangle that's a special kind of triangle. It has to have a right angle in the corner, meaning that it's 90 degrees. Then one leg will be A and one leg will be B, and then the hypotenuse that it points to the hypotenuse over here. This one is always the C. And so the Pythagorean theorem says if you take A and square it and add it to B squared, and then you'll have C. If you've ever watched the Wizard of Oz, they do a form of the Pythagorean theorem in the Wizard of Oz when the scarecrow gets his brain. So you can watch for that next time. If you get a negative answer, this is something you need to know. If you get a negative answer, then throw it away. Because you can't have a negative length. So on this problem, you might get a negative answer because we're dealing with squares and you're going to have that plus or minus rule. And so if you get the negative side of there, you throw it away. It's called an extraneous root. Sometimes I'll write ER for extraneous root. It's just a root that is not valid in the problem. Okay, now we're going to work one of these Pythagorean theorem problems in just a minute. I just want to introduce you to it, the Pythagorean theorem, and let you remember what it says, that it's a squared plus b squared equals c squared, and you're going to be doing it from a right triangle. So we're going to do a problem like that in just a minute. I want to give you the information first, and then we'll just jump into the problems and do as many as we can do. Okay. Well, the third thing that you're going to need from this section is if you have a problem like d squared plus d plus 2 quantity squared equals 10 squared, then you need to multiply the binomial out first. So you would have a d plus 2 times d plus 2. That's the problem that most people make out of this problem, is that you forget that you've got to multiply that out. It's a binomial, so put it down twice. So that's something you're going to remember, and we're going to do that exact problem in just a minute. I just want to remind you that you need to put that d down twice and multiply it out. Consecutive integers. Consecutive integers are things like 2, 3, 4, or 10, 11, 12, or 5, 6, 7. Those are things that come one right after the other. And the rule for this is to let x be the first consecutive integer. Then x plus 1 will be the second consecutive integer. That's the rule that you want to remember. And we're going to do a problem like that in just a minute. Okay. Number 5. These are rules and that I'm going to go over again for factoring. And I'm going to actually do some examples. I think that some people are still having trouble with factoring. So we're going to go over each one of the rules again, because you're going to need it for this section. if you have t squared plus 4t minus 21. Notice this is not an equation, it's an expression, and we're supposed to factor it. This is a simple trinomial because it doesn't have a number here in the front. So all I'm dealing with is this number on the end. The last sign tells me what I must do. I must subtract. What am I subtracting? Factors of 21. I'm sorry, what?
The words are blurry.
Yes, it's a little blurry. That's more better.
Did it just adjust itself?
I guess so. It's slightly better. It's still a little bit blurry, but better than
Let me
it
hit
was.
one of these controls up here and see if it'll help. Did that help it or not?
Yes, that's better for me.
That's better.
Okay. All right, well, tell me. I can switch to a bigger pen if it doesn't work. All right, so I must subtract factors of 21. So if I do 7 and 3 and I subtract them, I do get 4, which is what I want in the middle. I want this 4. I want the 4 to be positive. So if I let my 7 be positive and my 3 to be negative, that will make a positive 4 in the middle. And notice I've used factors, which two things multiplied together to get 21. So now I'm ready to factor it into t plus 7, t minus 3. Okay, let's try another simple trinomial. If I have b squared plus 11b plus 10. Notice that my last sign on this one is a plus. That means I must add factors of 10. And I want to get 11. 11 is what I have in the middle. So can anybody tell me what factors I can use to get 11 in the middle?
10 and 1.
That's right. 10 and 1 would give me 11 when I add them. I want 10 to be positive and 1 to be positive to get a positive 11. So now I'm ready to factor b plus 10, b plus 1.
I knew that.
Got it? Now those are simple because there's no number in the front. Those are called simple trinomials. Now let's try one that's an AC trinomial. This one takes a lot more work. 4x squared plus 25x plus 36. See it how it has that 4 in the front? That tells you it's an AC trinomial because the A is 4 and the C is 36. So if I did AC, I would have 4 times 36. And 4 times 36 is 144. Now I'm using my rules. This last sign means I must add factors of, now it's 144 instead of just the last number. And I'm trying to get 25. Well, 12 and 12 won't work. That gives you 24. 4 and 36 won't work. That gives you 40. But if you try 9 and 16, you would get 25. You want your 9 to be positive and your 16 to be positive. You get 25. And 9 times 16 is 144. So those are the factors I want to use. Okay, this is the way, this is that Merrill method. You bring down the first term, you bring down the last term. And the middle term, you rename according to what you have over here, the 9 and the 16. So I'm going to say plus 9x plus 16x. And you can see that 9x plus 16x is 25x. I've just split up that 25 into the two factors that I needed to add together to get 25. Okay, now the next step is to group. Now we have all these written down, and they're written down in your notes as well. But the next thing is to group, and group underneath it instead of with parentheses so that you won't lose the sign. Now after you group, you take out a GCF. So I need something for 4x squared and 9x. Does anyone know what that would be?
X.
X. And I would have a 4x plus 9. And if you want to check it by multiplying it back to see if you get 4x squared and 9x, or we can do it like Brooke mentioned the other day. We can do it like this and split them up, take out an x out of both of them because that's what they have in common. And you can see that you have a 4x plus 9 left. Okay, now if I want a 4x here, it's easy for me to see that if I take out a 4, that would leave me a 4x there and a 9 here. But that, and besides, that's what they have in common. So I have a 4x plus 9, and this is the magic of it. Each little group that you factored out will always be the same. 4x plus 9 and 4x plus 9 is your common factor.
And that's only for AC trinomials, correct?
You can do these for simple trinomials. You can do the same.
Oh, okay. But it's like a must match for the AC trinomial.
Yeah.
Okay.
Well, it's must unless you learn to do it by trial and error in your high school era and you were more right than wrong, because you can do these straight to the two factors as long as you get them right. The problem when you have a number like 144 is there's so many multiples. If you don't have an algorithm to follow, you'll be doing a lot of trial and error trying to break up 144 to get it right. You have to multiply your outer and inner terms, and that's called trial and error method. And I quit using that a long time ago because it taxed my brain to try to figure it out all the time. And that was the only method we had when I was a student. So I can remember struggling because we would have huge numbers. And then Dr. Merrill came along with this method, and I've used it ever since because I don't have to think too much. If these two match, I know I've got it right. All right, so those two that match will be one of the factors groups, and the other one will be the fronts off. This one and this one go in the other parentheses. I like these things that have a check built in to see if I've done it correctly, because then makes my problem easier and I can go on without struggling to think if I factored it right or not. There are other methods than this. This is just the one I prefer because in my teaching history, it's been more successful than any of the others. Okay, you're going to run into a problem that looks like this. A squared plus 5a. And you've been doing these kinds, so you're going, gosh, I don't know what to do with that thing. Well, they're just asking you to factor it. This is a times a, and this is 5 times a. And the only thing you can do is take out a common factor of a in both places, and you'll have an a plus 5. So don't let that easy one confuse you that's right in the middle of all the hard ones. Okay, now then there's the kind like some of you remember. This is usually the one most people remember from high school, is the difference of two perfect squares. X squared is a perfect square and 9 is a perfect square. So you split your 9 up into 3 and -3, and then draw your two little parentheses, x plus 3, x minus 3. Most everybody can do that with that one because you've probably done more of those than you've done the others. Okay. We're going to start in a minute with some
Can I
problems.
see the bottom part of that? I was still writing it. I'm
Okay,
sorry.
sorry. We're going to do some problems that ask us to just multiply. And so I want to do one of those before we get started because I'm afraid that you'll have all these exponents and you probably need to see one or two before we jump in there to do these problems. Are you finished?
And it says did you say difference of two
Difference
per
of two
square?
perfect squares. I'm sorry, I didn't write it out. It's written out on your notes and that's posted, but I didn't write it out here. I'm sorry.
No, that's fine.
I'll do better.
Okay, I got it.
Okay. If you have a problem, and you will, that looks like this, x to the 4th plus 2, and it says quantity squared, and your direction doesn't say solve, it says to multiply. Then remember this little 2 is going to have you write this down twice, is what it's going to do. X to the 4th plus 2, and x to the 4th plus 2. And then what you're going to do is FOIL it out. Okay? So x to the 4th times x to the 4th is x to the,
8.
good.
8.
And then the outer one is going to be 2x to the 4th. And the inner one's going to be 2x to the 4th. And the last one's going to be 2 times 2, which is 4. And don't leave it like that because these two in the middle are like terms. So you'll want to combine them. So you have x to the 8th plus 2 and plus 2 is 4. 4x to the 4th plus 4. And look, see this leading exponent just while I'm waiting for you to write this down. That thing, if it happened to be an equation, could have as many as 8 answers for this problem. It could cross the x-axis in 8 places. We will do those polynomial functions a little bit later. All right, let's try this one. This is our last one that we need to look at before we start our actual problems for this section. And then we're going to get our problems done, and I'm going to do 6.1 after this and get you started. 6.1 is really a lot easier than this one is. This one's the hard one, this section. If the question asks you to solve, set the equation equal to 0. Okay? So it says, this one's the verbiage on this, and it's a little bit hard to understand. Find A, so f of A equals 3. Remember, f of A is just y, so they're saying y is equal to 3. And they give you a function, f of x equals x squared plus 13x plus 43. But they want to know what A is, what's the x value or the value right here, if the y value is 3. Okay. Now you can change all of your X's to A's if you want to, if that bothers you to have those X's in there. We can write f of A equals A squared plus 13A plus 43. And that way you can feel like you're solving for A. Just substituting the X's for A's. And now substitute this f of A for 3. Now, most of you will probably try to jump in there and add factors of 43 to get 13, but that's not what you do. This on this side must be 0. You can't start this quadratic equation solving until you have a 0 over there, unless there is no linear term, and then you can use the square root method. But this one has an A term. Yes, questions?
Subtract 3 and then factor it. Is that what we're doing?
You're going to have to subtract the 3 off first before you start factoring.
And then you factor after the 3, so it'd be plus 40 when we factor that. Oh, okay.
Now, can we add factors of 40 to get 13? You must add factors of 40. This is a simple trinomial to get 13. Anybody know?
8 and 5.
8 and 5. That will give me 13, and I don't have to do first down, last down, rename the middle, although I can. It will work that way for these problems as well. I can go straight to factoring for a simple trinomial. A plus 8, A plus 5. Now I have to set, because this is solving, I have to set each one of these. I can't stop with the factoring. I have to set each one of the factors equal to 0. So I have A equals negative 8. A equals negative 5. And on the set, it says the A equal part, and there's a place for you to put in negative 8, comma, negative 5. All right, any questions on that?
I felt like a little light bulb going on in my head after I subtracted a 3. I was like, oh, okay, they're trying to confuse me.
Yeah, they are trying to confuse you. You're right.
Yeah, it's actually, after you wrote it out, I'm like, okay, well, you just make it equal to 3 and subtract it. Okay.
All right, let's do the college algebra section of this one first. They're probably the harder of the two problems. So we're going to do, this is the college algebra section. It's section 4.8. These are the problems that we're going to be doing. Number 1 says use the graph. And it has a graph in my problem crossed at -2 and 5. And it came down here. It was a smiley face parabola, and it looked like that. -2 and 5 are the places where it crossed. And this is one that says the x-intercepts are, and it has a blank. And underneath there it says use ordered pairs, because it's asking for x-intercepts. So someone tell me what I would write.
You would write -2 or parentheses -2 comma 0, and then parentheses 5 comma 0.
That's correct. Don't forget to put the comma between your two parentheses. I don't think they'll count it wrong, but they might. Then there's another blank that says the solutions are.
-2, 5.
That's correct. Then they give you an upside down one. And the upside down one crosses at -1 and 5, and it does the same thing. The x-intercepts would be -1, 0, comma, 5, 0. The solution would be -1, comma, 5. Remember, they could have used the word zeros or roots or answers. Those are all interchangeable. Okay, let's look at number 3. Number 3 is a problem that has, let's just look at it. And you don't have to write all these words down. You can just write the math for it because you'll have a just like it. It's a wire problem just like this. It says a wire is stretched from the ground to the top of an antenna tower. The wire is 10 feet long. So let's do that picture that we have so far. So this is going to be my tower. It's up here. And I'm going to have a wire that's stretched. This is my wire. This is the tower. Okay. And the wire is 10 feet long. It's stretched from the ground. So this is my ground down here. There's my ground. It's going to be stretched from the ground to the top of the tower. The height of the tower is 2 feet greater than the distance from the tower's base to the end of the wire. Okay, the distance D is from the tower's base to the end of the wire. So that distance is D, it says. Then it says the height of the tower is 2 feet greater than the distance D. So 2 feet greater would be D plus 2. Now I'm going to stop a minute and see if you understand where I got all those numbers and letters. And your problem will be exactly like this. This 10 may say 12, and this might say 3, but this D is probably going to be D here. It's probably not going to change. It'll be this number and this number that'll change, so they'll look just like this. Okay, now remember I told you you're going to work with some right triangles. Does anybody remember what the Pythagorean theorem says?
A squared plus B squared equals C squared.
So my A is going to be D, my B is going to be D plus 2, and my C is going to be the hypotenuse, which is the side that this right angle points to. So I'm going to substitute in here for A squared and put D, and I have to square it according to the Pythagorean theorem. B squared, B is D plus 2, and I'm going to square it. And C is 10, and all of those are squared. So when I get this problem worked, I will have the answer for D. It asks, find the distance D and the height of the tower. All right, remember on our notes where I told you that you're going to need to multiply this one out? So I'm going to rewrite this, D squared plus D plus 2 times D plus 2 equals, and I can go ahead and put 10 times 10, which is 100 over there if I want to. Okay, I'm going to multiply D times D, which is D squared. Outside is 2D. Inside is 2D. And last is 4. So I have D squared plus D squared plus 2D plus 2D plus 4 equals 100. All right, remember that problem that we just did a few minutes ago where we had a number over here? What do you think I'm going to have to do to that 100?
Subtract it.
This, if it's quadratic, it needs to be set equal to 0, not 100. So I'm going to subtract off that 100 when I'm combining these terms at the same time. So what's 1d squared plus 1d squared?
2d squared.
And 2d plus 2d is?
4d.
And 4 minus 100 is?
96.
Now I have a 0 over there, which is what I want. Okay, now I'm ready to factor. Well, it looks like I have an AC trinomial, but if I'm careful, I'll see that there's a 2 in each one of this. So I'm going to factor out 2 first. When I factor out the 2, I'm going to have a d squared plus 2d minus 48 equals 0. Now, sometimes I have to put this equal to 0, but I don't in this case because there's no variable with 2. It's just a number. So I can divide out that 2, and it'll go away when I do. And I have d squared plus 2d minus 48 equals to 0. Okay, I'm ready to factor. I must subtract factors of 48 to get 2. Does anyone have an idea what that might be? 48, I need to figure out what I would multiply so that when I subtract, I get 2.
6 and 8.
6 and 8. And I want my 2 to be positive. So that means my 8 needs to be positive and my 6 needs to be negative to get a positive 2. So I have a d plus 8 and a d minus 6. So I set each one of those equal to 0. D plus 8 equals 0. Gives me d equals negative 8. D minus 6 equals to 0. D equals 6. Now remember when I told you that sometimes you get a number that doesn't work. It's called an extraneous root. Because we're looking at distance for D. Distance is the distance from the wire to the base of the tower. I don't have a measuring rule that will measure in negative numbers. If I get a rule from out of my drawer in there, it's going to only be positive numbers on it. So I have to throw this one away because it's an extraneous root. I can't have a negative amount of feet.
So in this problem, there's only one answer, d equals 6.
D equals 6 is the only answer for D. But there is a relationship between these two numbers, and you'll see what happens. My D is 6, and that's the distance from the bottom that goes along the bottom there. Then I have another distance, the distance D and the height of the tower. The height of the tower is D plus 2. So I need to find that value too. So that would be 6 is D plus 2 would be 8. And it's almost always what the opposite of this one would be. If this is negative 8, then your other answer is going to be the positive side of it. So my answers will be, it'll have two separate things. It'll say, what is the distance from the wire to the base of the tower? And that would be 6. Then it'll say, what is the distance for the height of the tower? And that would be 8. That's the height of the tower.
So this problem will have two parts, technically.
It will have two parts, two
Okay.
different blanks to fill in. And it will
Okay, thank you.
actually ask you in words.
Okay.
The distance from the wire to the tower is blank. the height of the tower is blank, and it will
I
ask.
also have one more question, sorry.
It's okay.
When you divided out the 2, can we do that with future problems as well, or does it just depend on the problem?
Can I say again? I'm sorry.
See how, like, when you divided the 2s, the
Uh-huh.
0 divided by 2, can we do that on other problems too, or does it depend on the problem?
Depends
I've
on
never
the
seen it
problem.
before.
That's why I did this one tonight, because I thought, I bet they've not seen that before, that you can factor out a
Yeah.
common factor. It's just because they have a common factor in all these
Okay.
parts.
So there's an exception why you were allowed to do that. Because I was saying, I don't remember learning that in school, the dividing
Mhm.
part.
The reason
Okay.
you want to do it is because it makes your trinomial a simple trinomial, and it
Yes.
helps your work to be a much easier problem.
Okay. Thank you.
You're welcome. Good question. All right, let's talk about the last one that's the word problem in this section. And it's the one that has, it's another one just like that. It says you've got this ladder that goes up, and it's 7 feet from the wall. So this is your wall right here. And 7 feet from the wall, there's this ladder that goes up. There's your ladder. I'll just make it look like a ladder, kind of. All right. And it's 7 feet from the wall, it says. The height that the ladder reaches on the wall, so this wall, the height that the ladder reaches on the wall, and the length of the ladder are consecutive integers. So let x be the first consecutive integer, and that's going to go where the wall is. Then x plus 1 equals the second consecutive integer. So that's the ladder. Okay, you have a right angle here. So you're doing the Pythagorean theorem. Okay.
So you set that up because height comes first in the sentence. Is that correct? Like the height that the ladder reaches, that's why I chose that as x, correct?
Yes.
Okay, I just want to make sure. 'cause I
And
wanna-
not only that, Daniel, but this has got to be the longest side. The hypotenuse is always the longest side.
Okay. I just want to make sure I set these up right before I
So
solved it.
it has to be bigger than this one,
Okay. Okay.
because the one that goes across like this is the longest side.
Okay. That makes sense now. Thank you.
All right, let's see how this is going to look in Pythagorean theorem. 7 squared plus x squared equals x plus 1 quantity squared. So I have 49 plus x squared equals x plus 1 times x plus 1. Don't forget to multiply that out. That's going to be 49 plus x squared equals x squared plus 1x plus 1x plus 1. First, outer, inner, last. Okay. Now, it looks like it's going to be quadratic, but it might not be. Let's see what happens. If we subtract x squared from both sides to get this x over here, look what happens. It's going to make those x squares go away. And you'll have a 49 equals, and I'm going to combine these two to make 2x plus 1. Now I've lost my squared terms. They canceled each other out. So what I have is a linear equation to the first power, and I can just solve this one by subtracting 1 for both sides. And I have 48 equals 2x. Divide out the 2. and I get 24 equals to x. And notice that it asks not what is the x, but how long is the ladder. The ladder is x plus 1. So that's 24 plus 1, which is 25. Be careful or you'll put the wrong answer in. You'll put 24 in instead of 25 in. Any questions?
I was a little confused why we didn't subtract the 49 from the other side. I guess because we only need one answer for this problem.
Well, when I first did it, this is my work. I did do that because I saw this was quadratic and I did subtract them from both sides. Do you see that? And then I ended up with a 0 over here and I discovered that my x squares went away. I just had a 2x and a 48. So then I added it back. So you can do it that way because you're so used to letting it be 0 over here. You can do that, but when your x squares cancel, you don't have an x squared term to have to make it set equal to 0. You can just solve it like it was just a plain old linear equation by adding your 48 back and then dividing out your 2 to get your 24. I had already done the problem once, so I said, Brenda, I know that those x's are going to cancel out, those x squares. So I'm going to be smarter this time, and I'm just going to do this side and get the 2x plus 1, and then I just can save myself 2 steps by subtracting 1. If you didn't know that, you could have gone the other way and set it equal to 0 and then had to add the 48 back. Does that answer your question?
Yes, it does.
Okay. All right, let's do a poll question real quick before we do the support for this section. I have a poll question for you if I can get it to come up. Let's see who all's here. Can you see it? It says, which method for solving a quadratic equation works for every quadratic equation? Which one do you think? We have 19 people on tonight. Did Portia ever come in? Is Portia here? Or Kiera? Okay, we have a couple of people that haven't voted. There's there is a right answer to this, but you don't have to get it right. It doesn't count against you if you get it wrong. Three more people. Some people are on their iPhones and they may not can vote. Okay, let's end the voting and see what we've got here. It's overwhelmingly quadratic formula from the class, and that's the truth. You can do solve every problem that's quadratic by the quadratic formula. It's a longer route to do for some of the problems, but not every problem will factor because sometimes you can't add or subtract the factors of the number on the again to get the number in the middle. And you have to use the quadratic formula then. Graphing you can't always do because sometimes they're imaginary roots and those don't show up. They're above the x-axis, and all that tells you is that they're imaginary. It doesn't tell you what they are. Square root method doesn't work every time because sometimes we have a linear term, an x term, and so we can't always use it. But if you get stuck on the test, know that you can always use the quadratic formula and it will work for every quadratic equation. Any question about that? All right, let's move on to the second half of this. And I'm not going to do every problem because I want to do 6.1 tonight as well. But I think this support section for 4.8 will not be too bad since we've talked about it several times tonight. But we'll see. Let's start. Let's do number 1. Number 1 says multiply. Multiply. And you have a 3r, and this one has a fraction in it, which is why I wanted to do it tonight. Has a fraction. Mine says 1/5. Yours might say 1/3 or 1/8. So they'll have the same kind of problem for number 1. It just might be a different fraction or a different number in the front. So remember, this little 2 means that you're going to write it down twice. 3r plus 1/5 times 3r plus 1/5. And you're going to FOIL it. First, outer, inner, last. Okay. So first would be 3r times 3r, which is 9r squared. Outer. This one might be a problem. 3 times 1/5. 3 can be over 1. 3 times 1 is 3. 1 times 5 is 5. So that is 3/5, and you have an r. So if that's true, then the inner one's going to be 3/5 r. And then the last we might have to come over here and write down. The last is 1/5 times 1/5. 1 times 1 is 1. 5 times 5 is 25. So the last one is 1/25. Now these two in the middle you will want to combine. So you'll have a 9r squared and 3/5 plus 3/5. You have a common denominator of 5. And you add your numerator and you get 6/5. And don't change it to a mixed number. Leave it 6/5. 6/5. Okay, now notice we're not solving, we are multiplying. So we don't do anything else to it. It's not equal to 0. All we're doing is multiplying it out. Any questions about that? Okay, I'm going to skip down to number 4. Number 4 is 3r squared minus 4t squared quantity squared. So again, I write it down twice. The exact thing, and same thing in each one of the little binomials. And then I FOIL it. Okay. 3 times 3 is 9. R squared times R squared is R to the 4th. Then outer is going to be 3 times 4, which is 12, and it's negative because positive times a negative is a negative. And you can put RT squared or TR squared. You can put R squared, T squared, or T squared, R squared. It doesn't matter which way you want to put the variables. They'll count it both ways because that's a product. Now then, to do the inner, it's the same thing. 12R squared, T squared. And then last, a negative times a negative is a positive. And again, I have common terms in the middle here. R squared, T squareds. I have a negative 12 and a negative 12, which is a negative 24. R squared, T squared minus plus 16t to the 4th. Forgot. Okay, let me write that again. 9r to the 4th. These two in the middle combine to make 24r squared t squared. Then I have this last term that's plus 16t to the 4th. And again, it's not solving, it's multiplying. So I don't have to set anything equal to 0 or solve or graph or anything like that.
you leave that 16 to the fourth at the end, or do you have to move it to the front?
That's a great question. When you have two variables that are to powers like this, you let one go down and the other one go up. So you wouldn't put them both at the front, but if you've got R listed first, you let the R to the fourth, and then the next step, the R would go down a step. And then the T would start, it starts with T squared, and it would go up. You see what I mean? One variable goes down in exponent, the other variable goes up in exponent, but you wouldn't put the 16 in the front. Although he shouldn't count it wrong if you didn't. It's just not generally the form we use.
Okay, thank you.
Great question. All right, I don't know if you can see this or not, but I wanted to, there's a lot of words here. So I wanted to see if we could just talk about this one. I'll tell you what it says in case you can't see it. Wish we had a zoom of some sort to put on here. It says determine whether the sentence is true or false. That's what it says, true or false. And it has if x plus 2 times x plus 3 is 24, then x plus 2 is 24, or x plus 3 is 24. So they're saying, can we leave this 24 over here? Or do we have to subtract the 24 off and get it to equal to 0? So what do you think? You have 4 answers. The first one says the sentence is true. Solve x separately in each equation. There'll be 2 values for x. Discard the negative. The sentence is false. Although the left side is the factored form, the right side is non-zero. The sentence is false because the left side should be written in standard form before factoring. And D, the sentence is true because the left side of the equation is in factored form. So, what do you think? How about this one? It says the left side of the equation is in factored form, which it is. The right side is not 0. So that's why you can't set each one of them equal to the 24, because the right side has to be what? Anybody know? What does this right side have to be?
It's so blurry, I can't read nothing.
Okay, the right side has to be a 0. You can't leave those numbers on the other side. We had one like that a while ago where we had a number on the right side like this one. See, most of these quadratic ones we have to set equal to 0. Let's find another one. There's one. See how we had this 3 over here? We had to subtract this 3 off and set this equal to 0 before we could do it. It's because that right side of that problem has to be a 0. So your answer is going to be that number B, letter B. Okay, the second one says every quadratic equation has 2 solutions. And this should say over real numbers. It's because you're in the real numbers section that they're saying that's true. Okay, now the answer to that, remember that first little diagram I drew that the graph could come down like this and you would have 2 answers? The graph could come down and touch and you would have 1 answer, or the graph could come up here and you would have no answers. So the answer to that one is false because sometimes you have 1 solution and sometimes you have no solutions, is what that sentence says. And this last one says, determine whether the number 0 is never a solution of a quadratic equation. Do you think you can have a 0 as a solution to a quadratic equation? Is it possible the graph could come down and cross at 0? Is that possible?
I can't really see it. It's blurry.
This graph, can you see the graph?
Kinda. It's blurry on my end. I might have to refresh my browser.
Okay.
I can't see anything either.
The answer is yes, the graph can go down through a 0. So a 0 can be a solution. 0 can be a solution. Okay, next time I do this, I'll try to enlarge those prints. Okay, now the rest of the assignment will be multiplying out those little binomials and solving quadratic equations. So I think that you can do all of the other problems. If we have time at the end of the class tonight, I'll go back and pick up those last ones and work backwards. Let's talk about the second section. We've got to do 2 sections tonight, and thankfully this section is not difficult. It's pretty easy actually, and you could use your calculator for most of the problems. So this is section 6.1. I'm skipping across to get 6.1 tonight because it's easier. This section has a domain section, and you want the domain for a square root problem. Okay, so let's see what that looks like. If you want the domain for f of x equals the square root of 5x plus 8. And this is the kind of the first or second time you've done domains for square roots. You'll do a bunch more. Then what you're going to do is know that this is a square root problem. So if I had f of x equals the square root of x, the graph would look like half of a parabola. That's the way it would look. Notice there are no values over here in the negative side of x, and there are no values down here in the negative side of y. All of the values are from 0 to positive infinity for both x and y. So that means, you know, like we had fractions that we said not equal to 0, it's similar to that. You take this number underneath here, which is called the radicand, and you take your 5x plus 8 and you set it greater than or equal to 0, because see, all these values have to be greater than or equal to 0. It can be 0 because it touches right here at 0, and you can have the square root of 0. The square root of 0 is 0. So to get the domain, you find your numbers under here, everything that's there, and put it greater than or equal to 0.
So it will always be greater than or equal to 0 if it looks like that?
It's always going to be greater than or equal to 0 because
of the square root of x. Okay.
if it was a negative number, you'd have an I in there and you couldn't graph it, at least not
Okay.
in the system. So now we solve it by subtracting 8 from both sides, and we get 5x is greater than or equal to negative 8. Divide out the 5, and x is greater than or equal to negative 8/5. So they want the domain just like this. It will look like this. Sometimes they put domains in interval notation, but this one looks like this, and it even has the x, and you have to put this part, greater than or equal to negative 8/5. That's what you have to put in. And there will be a greater than or equal to symbol for you to use. Okay. Another part of this assignment actually has 4 options, and it'll have this part, and it'll say greater than or equal to, greater than, less than or equal to, less than. And you have to pick the one that you want and put in the -8/5. That's another option that they have. They pick 4 of them. They'll have a x such that x is greater than blank. B will be x such that x is greater than or equal to blank. C will be x such that x is less than blank. And D will be x such that x is less than or equal to blank. That's another way that they wrote the answers for some of these. And you have to pick the right one you want, which would be this one, and then put in the -8/5. You just put the number in. So there's 2 ways they do it. One is where you actually write in there, and the other one which you select the answer that you want. Okay. The second part of this we've already done in class. The second part of this is linear inequalities. And you will remember doing this before, I hope. If you have a plus 5 is less than or equal to -10, subtract the 5 off, and so you get a is less than or equal to -15. So the solution would be a such that a is less than or equal to -15. And I think they just have this part in there. You have to put the number. The second part is a graph. And remember that if we had less than or equal to or greater than or equal to, we use brackets. That's the same thing. Less than or greater than, we use parentheses.
Hey, Chandra, I'm next.
Okay.
I'm next. Give good back scratches.
Let's see what happens. A is less than or equal to -15 would be a bracket, and it goes to the left. So hopefully that will be easy for you to do. We've done these before, so this is like the second time we've done those kinds of problems. All right, so let's look at these and see what they're going to look like. Okay, this is 6.1, and it's from the college algebra section. Number 1 says determine the domain. And it says f of x equals the square root of 3x plus 5. So somebody tell me, what do I do?
You
You're
take
gonna
the
say
3x
that.
plus 5 out, set it greater than or equal to 0.
You're taking this 3x plus 5 out from underneath there and set it greater than or equal to 0. Now subtract the 5 from both sides, and we have 3x is greater than or equal to -5. Divide out the 3, and we have x is greater than or equal to -5/3. Okay. Number 2, the rest of these are really easy because what they say is graph. And they give you choices. They have one that looks like this, one that looks like this, one that looks like this, and one that looks like this. And so what you're going to do is put that, this is A, B, C, D, put that in your calculator. So grab your calculator and you do y equals 4 second square root x graph. So which one is it? Were you able to graph it?
B.
It is B. And what happens on this 4 is it makes it higher. It makes it go up higher and faster. That's what it does. It makes the curve is steeper, makes it higher up. You're right. It's that one. Okay. Let's try number 3. Number 3 is f of x equals negative 3 square root of x. And this one, the A, looks like this. B looks like this. C looks like this. And D looks like this. So what you have to do is put negative square root of in your calculator and see which one it is. Somebody do it and tell me what you got. The negative is that negative down there by enter.
I got A.
You got A. A is correct. Everybody got it? Should look like this. This negative on the outside is going to flip that. See, this is a positive 4, which was this one. See how it goes up like this? And 4 is almost as big as 3, but the negative is going to flip it or reflect it across the x-axis. We learned that last time. That's what they do. All right, let's try number 4. Number 4 is f of x equals 5 square roots of x. And so A looks like this. B looks like this. C looks like this. And D looks like this. So which one would you say it was by what you know already?
B.
Yep, it's B. See, it looks just like the 4 did, except it's going up even steeper. All right, number 5 is f of x equals the square root of x minus 9. And A looks like this. B looks like this. C looks like this. And D looks like this. So grab your calculator. And you already know what it does because that's a horizontal shift there. You're doing second square root, and this time you're going to put the x and the 9 underneath the radical. Make sure they both get under there before you graph it. Do x minus 9. And which picture did you get?
B.
It's B. Now your little marks off. This goes to 20. This would be 20, so 9 would be like right there. But it's easy to see. The others aren't anywhere close. Number 6 is f of x equals the square root of 20 plus 4x. Okay, so the first graph looks like a straight line that goes this way. That's A. B looks like a graph that goes this way, and this number over here is 10. C looks like a number that goes this way, and this number over here is 10. And D looks like a number that comes up this way, and that's 10 that's down here. So which one do you think it is?
C.
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 Let's see. Did somebody say B?
C.
C.
C is in cat.
Oh, C and was in cat. Yes, it's C.
I said C, but I sounded bad, so that probably came off as B.
All right. Now, you see, these are not going to be bad. There's only one more of these. It's g of x equals the square root of 3x plus 2. Your first graph looks like this. Your second graph looks like this. Your third graph is a line. And your fourth graph is one that looks like this. So which one do you think it is?
D.
Think it's D?
Yeah, D.
I don't think so. That's too far over, isn't it? Isn't it going to touch at 3/2? Let me see that.
I got B.
It's
That's
closer to A,
right.
but
3x 2. Yeah, it's just really close to the front right here. That really should be 1.5 where it's coming in. This is on the negative side. I don't think it touches down on the negative side, does it? I think this answer's got to be A.
Mine shows it a little bit on the negative side, but not a lot.
Mine says
If you second touch,
If you look at my
any
camera,
values on the negative
if you
side,
look at my camera, it's negative.
I don't think there's any values on the negative side. If you do your second and table, it shows arrows on everything
Okay.
that's
I
on
don't
the
know where the graph's showing now. Let me check my table though. You're right.
Yeah, mine is too.
Oh, it says error on negative, so I don't know why the graph is showing it. See,
Oh no.
that's weird.
Maybe you can zoom in and check it by zooming it in to see if it's really touching on any.
Yeah, it looks negative at first, so that's really weird.
Yeah, mine does the same.
Really? Mine looks
That's
like
how
it's on the positive.
mine is showing, but the graph is showing it. But I got a TI for a plus CE.
I didn't hear, say again. Mine doesn't look like it's going to the negative side at all when I graphed it. Okay.
So whenever I go to where my graph hits on the x-axis, my value for x shows negative 0.530303.
Uh-huh. Yep. Does it say a 0? Does it say a negative? So maybe it is showing there. When you put your value in underneath there, did you put your 3x and your 2 underneath your radical?
Yes, ma'am.
I did too. I could.
hey, Shaquela.
I don't think we can hear Shaquela. I think something's wrong with her sound.
Yeah, she got T-Pain going on.
I'm here.
You got it sound like your thing it sound like robotic. Like when you talk, it's like really loud and it's like robotic.
Okay, I think she's got it fixed. All right, let's do a couple of these off of the last section, and then I'm going to go back to some of those other equations that you might have trouble with from that other set, because I think you'll probably find these are pretty easy. Let's do, this is from one, and it's the support section. Number 1 says solve, and it says x plus 7 is greater than 1. So you subtract 7 from both sides, and you get x is greater than negative 6. So the solution set is, and you pick the one that says x such that x is greater than, and you put in negative 6 in the blank. Then there's graphs down here, and you want the graph that has -6 with a parentheses because there's no bar underneath that greater than symbol, and you want it to go this way, to the greater than side. Any questions on that? Let's try number 4. Number 4 says 0.2x is less than -10. You just divide both sides by 0.2. And when you do that in your calculator, 10 divided by 0.2, that would be like moving the decimal place over 1. And when you do that, you get -50. So you're selecting the one that says x such that x is less than, and you put -50 in the blank. Then for the graph, you're looking at -50, and it's a parentheses because it's less than, and it goes this way. Any questions on that number 4? Okay, let's go to number 5. Number 5 says f of x equals the square root of 3 minus x. Find the domain. Okay, now we've done a few problems. Do you remember how we did domain a while ago for a square root?
Take the 3 minus x out and set it greater than or equal to 0.
That's the secret, setting it greater than or equal to 0. Now we have to be careful on this one. If you subtract 3 from both sides, you'll get -x is greater than or equal to -3. And look what I've got there. I gotta have a -x. How do I get rid of that -x?
Divide both sides by -1.
Divide both sides by -1. That's correct. And it's going to flip that inequality because I divided by a negative number. Okay, now then, they're going to ask you to put the answer in interval notation. So let's see what it looks like on the graph. Here's 3. It would be a bracket, and it's less than now. It used to be not, but it's now. So it looks like that. Now go left to right for interval notation. Down here is -infinity, and you always use the parentheses with -infinity. And it goes until you get to 3, and you put a bracket on the 3. And it will give you that choice. There's a bunch of choices on that, but that's a choice that you can pick from the multiple choice section. Any questions on that? Okay. Let's do number 6. It's find the domain. And again, it's a square root problem. So just remember that every time it's a square root and you want the domain, you take what's in there out and make it greater than or equal to 0. Then you add 6 to both sides. So x is greater than or equal to 6. So on a picture, a graph, it would be a bracket at 6, and it would go this way, over here to positive infinity. So if I wanted to do it in interval notation, I would go left to right and start with 6 and go to positive infinity. Then the last one they give you is they're trying to trick you. It's find the domain. And we'll see if they trick you guys or not. It gives you f of x equals 18 minus x. And they want the domain. So what would you say the domain is? Do we put 18 minus x is greater than or
18.
equal to 0?
Yes.
No,
No, because it's not under a radical.
that's right.
Oh, okay.
They're trying to trick you. See, that's what you would automatically do because you've been doing it, is put 18 minus x greater than or equals 0. But you don't do that one on this one. Why not?
Because it's not a square root.
There's a no square root. So this thing is just a line. It's a line. It's really negative x plus 18. It's going to go up here to 18, and then you're going to go down 1 and over 1. So it's just a line. Now, what is the domain of a line? Does anybody remember from
All real numbers.
all real numbers? And they're going to ask for it in interval notation. So you would go negative infinity to positive infinity. Okay. All right. Now we have about 2 minutes before 8. Then I want to go back and try to catch up the end part of these equations and make sure you can do them. So I'm going to start and go backwards on this set 4.8. I didn't know if I'd be able to get very many of them done, and I wanted to get 6.1 in. So we're going to go backwards on a few. Before we start, do we have any questions? Okay, this is number 20. Nope, this is number 19. 19, let g of x equal 2x squared plus 3x. Then it says find a so that g of a equals 20. Okay. G of a just means y, remember. So what we're going to do is make this to say g of a here, and then we'll substitute 2a squared plus 3a. We're just going to put a in for x. Okay, now we're going to put the 20 in this g of a spot. 20 equals 2a squared plus 3a.
You're going to subtract 20.
That's right. You got that one down, didn't you?
And then you're going to factor it. I don't know why, but these clicked for me compared to other stuff we've done.
All right.
Still
Now
working on the factoring part, but
can we take a 2 out of this one like we could on that other one?
No, because of the 3a.
Because of the 3. So this is an AC trinomial. A is 2 and C is 20. So AC would be 2 times 20, which is 40. And I must subtract
to get that.
To get 3. 40 and 10 won't work. That gives me 6. 2 and 20 won't work. That gives me 18.
5 and 8.
5 and 8. That's great. 5 and 8. If we subtract those, we get 3. We want positive 3, so we let 8 be positive and 5 be negative. Somebody's not silenced. Watch to see if you're silenced. Let me see who it is. Oh, somebody did it. Okay. So now 5 and 8 is what we want. So this is an AC trinomial. We bring down the first term, bring down the last term, rename the middle term. 3a would be negative 5a plus 8a. And somebody asked me, it doesn't matter which way you write these. It does not, as long as your 8 is positive and your 5 is negative. But it will make a difference in the next step on what your GCF is. So I have to group these now into 2 groups. In the first one, they have an A in common, and I have a 2A minus 5. In the second one, I have a 4 in common, and it's magic because I get a 2A minus 5. That's the same one. So I have a 2A minus 5 is my common group. A plus 4 is the front off of the other group. Set them equal to 0. And we have 2A is 5, or A is 5 halves. A plus 4 equals to 0. A equals negative 4. So they have A equals in the problems, and you have to put negative 4 comma 5 halves. Questions on that one? Anyone need more time to write it down? Did Kiera or Portia ever come on? I think we're missing them. All right, let's go to this is actually number 17. We did 18 earlier. This is number 17. 10W cubed equals 90W. This is a pretty interesting problem here. It has a cube instead of a square. But let's see if we can subtract the 90W and put a 0 over there and see what happens. So we're going to subtract 90W from both sides. And so we have 10W cubed minus 90W equals to 0. Let's see what happens. This means I'm going to have 3 answers. That's what that means. Okay, 10W cubed and 90W. If I'm looking for a GCF, what's something that will go into 10W cubed and 90W? Anybody know?
10W?
10W is correct. This would be 10 times WWW and 9 times 10 times W. You can take out a 10 and you can take out a W. So I have a W squared minus 9. Now that looks familiar. From this point, you can factor this as a difference of 2 perfect squares, or you can use the square root method, and either way we'll get it. I'm going to choose to do it as a difference of 2 perfect squares. W minus 3, W plus 3 equal to 0. Then I have 1, 2, 3 things to set equal to 0. 10W equals to 0. Divide out the 10. And yes, we can get an answer of 0 in our problems. There's one right there. W minus 3 equals to 0. W equals 3. And W plus 3 equals to 0. W equals negative 3. And this is going to be a cubic that crosses at negative 3 and positive 3 and goes down through 0. Looks like that.
And on this, will it want us to put it in like -303, like between commas, or
Yes, it says W equals, and then there's a blank. And
Okay,
you
and
can
they want
put
it
it
like
any way you want to with any one of them first. -3, 0, 3 is great. Just put the commas between them.
okay, but like we don't have to put it that way. I just don't want to get flagged wrong for having it not put in
It should
properly.
not it matter which order you put it in
Okay.
because they're
Okay,
three
just wanna make sure.
distinct answers.
Okay, nothing's more frustrating than solving something
I
and then
know.
you put it in and you get marked wrong.
I understand. And you're going, what? I know that's
And then
right.
it's like, and then you spend so much time on the problem. It's like, oh
Uh-huh.
my gosh.
Chandra is the queen of graphing close problems. Chandra is the one student in this class that can get every graph wrong she graphs, and she's like 100th off, and it counts her wrong. I know she gets so frustrated because she's just right there. I had to go back and count almost every one of her graphs right because she was just right on top of it. And I was going, what is the difference between this answer and her answer? And it would be, I'd trace it, and it would be like, honestly, it would be like 100th off.
Oh my gosh.
Yeah, I know she gets frustrated with that, but she's the queen of that graphing close business.
Yeah, I always have to zoom in because I'll click the wrong thing. I've done that a couple times.
Yeah. She gets them right, but the author does not like what she puts down. Okay, let's try number 16. 6w squared minus 54 equals 0. Now this one's got a squared term there and no linear value. There's no w. So you could use the square root method on this one. You're going to have 6w squared equals 54. Divide out your 6, and you'll get w squared equals 9. I could subtract the 9 and factor it into +3 and -3, but I'm going to take the square root of both sides. Square root of w squared plus or minus, don't forget you get plus or minus over there. Plus or minus the square root of 9. This side is just w. This is plus or minus 3. So I would have 3, -3 in my blank.
There was a problem on the homework and I forgot to simplify the last step. I was so mad.
Yes, if you don't simplify, they don't like it.
I looked at the problem like, oh my gosh, I forgot to simplify the radical. Are you kidding me?
All right. I don't think we did. Yeah, I don't think we did this one. 42s squared plus s equals 30. This is a stinker problem right here. But you can do it. It's quadratic, so you need to set it equal to 0. So we have to get rid of this 30. So you'll have a 42s squared plus s minus 30 equals 0. And this thing is an AC trinomial. That's 42 times 30. I think it was Eric or maybe Braylon that worked a problem similar to this with me. And it was nuts. He said something like factoring 1,250. And I went, oh, you gotta be kidding. Well, this is one of those problems. This one is, let's see what this is. This one is 1,260 when you multiply it out. So you must subtract factors of 1,260 to get 1. So they've got to be close together. Well, I started out with 42 and 30. So I've got to go down from 42 and up from 30. Does anybody have an idea what two numbers multiplied together would give us 1260? And when we subtract them, we get 1. Anybody have an idea? Well, I know they've got to be closer together than 42 and 30.
630,
So what'd you say? Say again.
630.
No, 630 will be too far away. We've got to have two numbers. One, the 42's got to go down and the 30's got to go up. So it's got to be two numbers that are lower than 42 and higher than 30 to get close enough together that when you subtract them, they get 1. So try 36. Somebody divide 36 into 1260 and see what you get.
36 and 35.
Yep, that's it. 35. Is that what you said? 35?
Yes.
Okay, so 36 and 35 will work. We want our 1 in the middle to be positive, so we make our 36 positive and our 35 negative to get our positive 1. So bring down the first term, bring down the last term, rename the middle term according to these numbers we got over here, plus 36s minus 35s. Okay, now 42 and 36 have a 6 in common. And there's an S in both of them. So we have a 7S plus 6. Now to get a 7 over here, I'd have to divide by 5, and 5 will go into 30, and my third term is negative. So I'm going to take out a negative 5, and that will give me 7S, and the negative will become a plus 6. And see, it's magic. 7x plus 6, 7s plus 6. So your two factors are 7s plus 6 is your common one, and 6s minus 5 is the one that's right here. And set those equal to 0. 7s plus 6 equals to 0. Gives you 7s equals negative 6. So s equals negative 6/7. 6s minus 5 equals to 0, gives you 5. 6x is 5, divide by 6, and s equals 5/6. So they're both fractions. S is, and there's a blank there, negative 6/7, comma, 5/6. That's going to be the hardest problem on this section, and it's only hard because the number that you get with A times C is so big. Okay, it is 8 o'clock. I can work a few more for those that want to stay. There is one that you're going to have to move the squared term to the other side that we'll probably want to do. And then if you don't need anything else, then I guess I will see you guys on Thursday. Thursday night, we will cover 7.5, and it's a little bit long. So try to get the work done on this section before you get that done. At least get the easy ones done. And then you can ask me about any hard ones that you have that you couldn't do. And I'll go in there and look to see which ones you couldn't do and go over some of them at the beginning of class. But I'll do that. And so then we'll have Thursday that we'll meet, and then Tuesday we'll meet, and then the next Thursday will be review for the test. So I reminded those people at the beginning that the midterm grades are out there. If you aren't happy with your grade, please contact me and let's make a plan for making sure that the grade gets to the point where you want it. No matter whether it's a B and you want to move to an A, or if it's a D and you want to move an A, then contact me and say, what can I do so that I can improve my grade, and we'll see what we can do to make a plan to get you up to a higher level. Okay. All right, so those of you that want to drop off, you can. I'm going to do one more problem off of this section for sure. It's number 13 because it's a backwards kind of problem.
Bye.
Bye-bye. I'll see you Thursday. See how this one's backwards because the C has a squared has a negative. You would like to have a C to be squared to be positive. So if I were you, I would just flip this whole thing by just getting them all to the other side, and then your 0 will come over here. So subtract off your 32, subtract off your 4C, and add your C squared to both sides, and it will get rid of all this negative stuff over here for the C squared and make it a positive C squared. Now, you need to put it in the right order. So write your C squared first, and then minus 4C, and then minus 32 equal to 0. And now it's easier to factor. You must subtract factors. And this is a simple trinomial, so you only have to use the 32, factors of 32 to get 4. So 8 times 4, 8 times 4 is 32, and if I subtract those, I get 4. I want my 8 to be positive and my 4 to be negative. So I can go directly to the little parentheses because it's a simple trinomial. And I have C and C plus 8 minus 4. Then I said each one of those equal to 0. We do such hard ones all the time that sometimes when you drop back to an easier one, you kind of forget how to do it. C minus 4 equals 0. Add 4 to both sides. So C is equal to 4. Any questions?